All right, guys. So we are, I guess, going to be working on some virtual lessons. So welcome to Bumbal's virtual classroom. So what I want to do is just go back over solving trig equations. I know we started doing that in class, so I just want to start from the beginning again and go through so that at least you have a reference if you have any questions. So going back to what we talked about, I said there were certain skills that you needed when you were going to solve this. And one of those, of course, is knowing where the trig functions are positive and negative on the coordinate plane. So that would be the all students take calculus. Then you had your two special right triangles. We had 45, 45, and the 90. And remember the sides are 1, 1, and then the hypotenuse is the square root of 2. Then we had 30, 60, 90. And the sides across from the 30-degree angle would be 1, and then square root of 3 across the 60, and then the hypotenuse is 2. You also want to know the unit circle, the coordinates, and obviously it's built from the 30, 45, and the 60 degrees, so you want to know all those coordinates and sine and cosine and so on. And then you want to know the period of your trig functions. So the period for sine and cosine, that is 2 pi. And then the period for tangent is pi. There are also going to be some trig identities, which I will talk about when they come up in solving a particular trig equation. Later on, we'll go into trig identities in much more detail. So let's look at the first problem that we worked on. So we want to solve 2 sine x minus 1 is equal to 0. And it was in the interval from 0 to 2 pi. So that was the interval that we wanted to solve. So the first thing you want to do is get your sine x by itself. So if we have this right here, I'm just going to rewrite the equation. I'm going to add 1 to both sides. So I get 2 sine of x is equal to 1. Then I'm going to divide by 2. And I get sine x is equal to 1/2. Sine x is equal to 1/2. So now what you want to do is figure out where is sine positive on the coordinate plane. So if you remember, all students take calculus. So sine is positive in quadrant 1 and it's positive in quadrant 2. So we're going to have an angle here and then we're going to have an angle here. That's where they're both going to be. So when I look at this right here, my options are, hopefully when you're looking at sine x equals 1/2, that rings a bell from the unit circle. You have the ordered pairs, the square root of 3 over 2, comma 1/2. Then you have the square root of 2 over 2, comma square root of 2 over 2, and it goes around the unit circle. Or you can use your special right triangle that we have over here and figure out, when am I going to get 1/2? Remember, sine, so katoa, so it's opposite over hypotenuse. So if I was at 30 degrees, opposite of hypotenuse is 1/2. That tells me that this is going to be 30 degrees, which is here. Or if you went to the unit circle, this is the square root of 3 over 2, comma 1/2, which happens at 30 degrees. Remember, your sine value is the y coordinate. So either way will work. You could also do the inverse of sine right here. So if I do the inverse, so I get x is equal to sine inverse of 1/2. And when you do that on your calculator, you would get 30 degrees. So x is equal to 30 degrees. So you have a bunch of options to use to figure out where that is, how you use the reference angle or the ordered pairs from the unit circle. So this right here is the quadrant 1 angle, which is 30 degrees. That is pi over 6, because we're going to want the answer to be in radians. Then this, from here to here, is our quadrant 2 angle. This right here would be your reference angle, which is 30 degrees. So from here to here is 150. and that would be 5 pi over 6 in radians. So x is equal to pi over 6 and 5 pi over 6. So now, if I wanted to change the interval, so let's move this up a little bit. So let's say that we want to find the answer in the interval from negative infinity to infinity. So that means we want all of the solutions. Now remember that the domain of the sine function is all reals. So basically we're going to have an infinite number of solutions. Well, how can we write that? So what we do is we use the fact that the period is 2 pi. So I can say that pi over 6 plus 2 pi n. Now if you remember correctly, when we talked about this, n represents any integer. So I'll write it over here. So n represents any integer. So basically -1, -2, -3 all the way, and 1, 2, 3, 4 all the way up. So all I'm basically doing is adding 360 and subtracting 360 to this all the way to infinity, which will give me all the solutions. And then here, this would be 5 pi over 6 plus 2 pi n. So it just depends on what I'm asking you. This right here is in the interval from 0 to 2 pi. If I want to go in the interval from negative infinity to positive infinity, this right here would be your answer. All right, so let's look at the second problem. So let me just slide this down a little bit to make sure I'm lined up. So number 2, we had sine x plus the square root of 2 is equal to negative sine x. So we're going to do this in the interval from 0 to 2 pi, and then we're going to do this from negative infinity to infinity. So let's start by writing out the original again. And we want to get sine by itself. So you can either move this over to this side or you can move this over to this side. So I'm just going to subtract sine x to both sides. So that would give me the square root of 2 is equal to negative 2 sine of x. I'm going to divide by negative 2. So I basically get sine x equals negative the square root of 2 over 2. So if I go to my coordinate plane, all students take calculus. Where is sine negative? Sine is negative here and sine is negative here. So my quadrant 3 angle is going to be this right here, and then my quadrant 4 angle is going to be from here to here. So now you go through all your options. You can use the unit circle. Hopefully the square root of 2 over 2 looks familiar, that those are always on the 45s. Or you can use your special right triangle, and sine again is opposite of hypotenuse. Or you can do the inverse of sine of both sides and get your angle and use that as the reference. So when you do that, you're going to wind up with, for your quadrant 3 angle, it's going to be 5 pi over 4. 5 pi over 4, because basically it's on the 45 degrees, so your reference angle here would be 45 degrees. This would be 45 degrees here, which makes this is your quadrant 3 angle. And then the quadrant 4 angle is going to be 7 pi over 4. So now that would be our answer for part A. It would be x is equal to 5 pi over 4 and 7 pi over 4. If we are listing this from the interval from negative infinity to infinity, then all I need to do is just say x is equal to, so 5 pi over 4 plus 2 pi n, and then 7 pi over 4 plus 2 pi n. And we're all done. So let's look at one more before I take a break here. So I'm going to scroll this up a little bit. So for number 3, we solved, it was 3 tan squared x minus 1 is equal to 0. So the first thing I want, and of course we're going to do this from 0, but this time we're going to go to pi because the period for tangent is pi. And then we're going to go from negative infinity to infinity. So when I write this out, I got 3 tan squared x minus 1 equals 0. So you want to get the tan x by itself. So I'm going to add 1. So 3 tan squared x is equal to 1. Divide by 3. So tan squared x is equal to 1/3. Now how do I get the tan by itself? This is squared, so you're going to do square root of both sides. And of course, when you take the square root of both sides, you have to add plus or minus. Now I'm going to simplify this a little bit to help me out in identifying what I need. So if I split this up, I can say it's the square root of 1 over the square root of 3, which is equal to plus or minus 1 over the square root of 3. Now you can multiply, if you want, the top and the bottom by the square root of 3 to get plus or minus the square root of 3 over 3. You might recognize this on the unit circle if you wrote yours on the unit circle. Remember, you're only given the coordinates, the x and y. If you did the division, the y over x, you might have those listed. It doesn't really matter. You can do the inverse of this right here. So tan inverse of the, you can just choose the positive. It doesn't make a difference, and you'll get your angle that you need, your reference angle. Or you can do your special right triangle. So here you got your 30, 60, and your 90. So this is 1 square root of 3 and 2. So this right here, the plus or minus the 1 over the square root of 3, that would help you to use the triangle, because remember, tangent is opposite over adjacent. So opposite over adjacent. So if at your 30 degrees, that's your opposite. 1 over the square root of 3 is your adjacent. So it doesn't really make a difference. So basically we know we have that 30 degree is what we really need as our reference. Well, on the coordinate plane, we're going to have an answer in all of these quadrants because it's tan of x equals plus or minus the square root of 3 over 3. So tangent is either positive or it's negative in all 4 quadrants. Well, we have both the positive and negative. But remember, we're only going from 0 to pi. So we just want an answer in quadrant 1 and the answer in quadrant 2. So this is our quadrant 1. This angle is going to be our quadrant 2. We already know that this is 30 degrees, which is pi over 6. This is your reference angle, which is 30 here, which makes from here to here 5 pi over 6. So x is equal to pi over 6 and 5 pi over 6. That is for part A. For part B, remember that we need to have these two plus, you have to add the period plus n. So x is equal to, so pi over 6 plus pi n, because remember it's the period n, the period of a tangent is pi, and then 5 pi over 6 plus pi n. So that takes care of the first 3 examples. And again, I'm going to take a break here. I think there's a total of 17 if I'm not mistaken. So I'm just going to break this part up, this section, which is solving trig equations, probably break it up into like 5 parts. So you can absorb each group of problems that I do at one time, and you can reference it. You don't have to look at a 45, 50-minute video with everything. So I'll just break it up. So I will see you next time. All right.